Hello everyone, this is Gyaneshwar Sairam Indrala from CSC Department A section, roll number 21951 As a part of my TikTok, today my topic is calculation of energy related quantities of conductors using surface impedance concept. Introduction. The surface impedance concept is usually associated with the approximate boundary conditions. Surface impedance boundary conditions SABC that are applied at the conductor or dielectric interface to remove the conducting domain from the numerical procedure and greatly reduce the amount of computer resources required for the computations. The concept is based on the approximation of original 3D equations of the electromagnetic field distribution inside the conductor by a 1D equation in the direction normal to the conductor's surface. Derivation derivation of SIBCs is the best known results obtained in the approximation. We focus on another application of concept, namely calculation of energy related quantities of the conductors, such as energy stored in the electromagnetic field in the skin layer and the power loss and the related per unit length PUL inductance and resistance. These quantities can be easily calculated when the distribution of the field inside a conductor is known. In the surface impedance concept, the field in the skin layer is determined by the field distribution over the conductor's surface. It enables on to restrict the numerical solutions at the processing stage in the dielectric region along the transverse calculation of energy related characteristics on the post processing stage. The method will be applied to the 2D problem of calculation on high, high, def, high frequency PUL parameters of LUSI, uniform and QZ-TEM multi-conductor transmission lines MTL of any kind of cross sections, taking into the account even a high proximity effect. In the in the context of magnetic vector potential MVP and the magnetic scalar potential MSP formulations, one of the most approach of the computational of PULN ammeters is the voltage filament technique, where the conductor volumes are divided into several filaments, each assumed to carry uniform circuits. However, at high frequency, the skin and the proximity affect the strong and elevated number of filaments should be used. For this case, a more appropriate approach is the surface integral equation method, digital object identifier, where only surface currents are modeled required such less memory uses and CPU time of stimulation. A standard, also called Lenotovic SIBC, has been already used with the FEM in order to reduce the computational size of the problem when computing MTL parameters. Here, the same standard SIBC is implemented with the BEM. Energy related quantities of a conductor. Balance of a power in a good conductors neglecting displacement current in a time harmonic segments is described as a polytiming theorem is transferred from the following equation. Here, the surface of the conductor and its volume, the first volume integral in the right hand side RHS represents the Olympic power represents the ohmic power loss that can be represented in the local coordinates as follows the assignment, where the tangential coordinates of the directed along the surface and the coordinate is normal to it inside the conductor. The second term of RHS of the equation 1 is proportional to the time time stored magnetic energy. According to the surface impedance concept, normal components of the electric and the magnetic fields in the skin layer can be neglected as compared with the tangential components. So, equation 2 and equation 3 in the Lenotovic approximation take the form here. The distribution of the tangential magnetic field and the current density are obtained from the solution of 1D equations in the skin layer approximations. Superscript denoted the quantities at the infer, infer, interface in the case of homogeneous conductors of constant properties of the material. Equation 6 and equation 7 admin extent solutions. In case of non-homogeneous conductors, solutions of 6 and 7 might be obtained numerically, being the problem of computation of PUL parameters on loosey MTL of constant cross section intrinsically 2D. Coordinate is the director along the conductors, considering a current flowing in a single wire and returning in the reference the PUL resistance and the internal inductance. Due to the magnetic flux internal of the wire can be calculated as follows, where denotes the cross section counter of the both wires in a tangential magnetic field has been calculated following the MSP formulation reported in equation 3. The application of 9 and 10 is straightforward based on 2. In section 3, an integral formulation in the terms of MVP will be diverted. MVP formulation. Let an external source procedure directed current flowing in the conductor, so the current density does not depend on under the hypothesis magnetic field is transverse of the axis and the MVP has only the component different from 0. In the following, the local coordinate is indicated with in the quasi-static approximation. The MVP is not conducting domain is described by the Laplace equation. So, application of BIE method gives the following integral equation over the counters of the following section of conductors. Where in curvilinear coordinate over the counter is the coordinate normal to the counter is non-dimensional coefficient depending on the counter shape. For smooth conductors, indicate the counter to the x conductors and the normal unit vectors in directed inwards the fundamental solution of the 2D Laplace equation by the following 10. The MVP can be separated in two terms, where represents the source component in the 2D case. It is a constant for each conductor represent the reaction field ED component. Submission of 12 into 11 yields. The following identity has taken into account. Equation 13 has two unknowns MVP and its normal drive and its normal derivative and the additional relation between the two is given in Leno, Lenotech SIBC equation 11, where and are connected and magnetic permittivity of the nth conductor respectively. For 2D case, the surface current is related to the MVP through the relation. And an integral equation of total current flowing in each conductors can be imposed as following. Equation 13 and to 17 can be solved to obtain functions, and we can seek for solutions in the following form. Where are unknown spectral components and unknown frequency dependent components, all complex quantities. Representation 18a and 18b makes it possible to separate variables in 13, leading to the following integral equations in the space functions. Where is a scalar factor and it is worth nothing here, that the zero order terms in 18a and 18b give the solution in the so-called perfect electrical conductor PEC limited, where the diffusion of the electromagnetic field is into a conductor is neglected and the current is assumed to the flowing on the conductor's surface only. Note the equation 19 to 22 have common form, so that disintegration scheme is same. And the equation where the sum or takes into the account the signal and the reference wire, substituting the representation 12 in 24, one obtains the following graph. Since in Lenotovic approximation and the taking into account 8b and corresponding expression for MVP, the PUL total inductance of the ith conductor can be calculated as following. As suggested by 9, once the source component is obtained from each conductor, the line self impedance can be also calculated as the following equation. And the graph is represented as following. Numerical results. First, the implemented BEM code is validating by the comparing numerical and analytical results for the canonical simple case of two circular identical copper conductors, radius 1 mm, distance between centers 3 mm, conductivity 5.8 10 seconds per meter for 10 meter per second, for which analytical solution is available in literature 12, figures 192. Each conductor is decreased with 40 constant elements. It is worth commenting that application of 26 or equivalency 27 with a PEC approximation with 1 0 order term. With the 1 0 order term gives the external inductance of the two wires according to the formula. Due to the lack of analytical solution, results of figure 3 corresponding to the rectangular conductors can be compared only with those provided by the other numerical techniques. Example, the hybrid technique introduced in 5 inaccuracies are due to the presence of the corners where the standard SIBCs fail, and the Formula 9 calculated using MVP formulations results in better accuracy. Conclusion. The present formulation is based on standard SIBC. In order to obtain better accuracy, higher order SIBC models should be used taking into account curvature of the conductors. Thank you.